Now, so no one would say adding fractions is a lot of trouble. Adding fractions is unthinkable. It's incomprehensible. Nobody's going to say that. Right? So this. The problem, like the fly in the ointment, is what? It was so pleasant when the denominators are exactly the same, right? But suddenly, paradise lost.
Yes.
Is it lost? What is lost? Oh, good idea. Yeah, right there, same denominator. Here, different denominator. Is that a big deal? Why not?
Equivalent fractions.
Huh?
Equivalent fractions.
Yeah, because I taught you to think. Looking at a fraction, the numerator by itself means nothing. The denominator by itself means nothing. You don't like the denominators? What do? Change them. That's one way to look at it. So you don't like it? So what do you change it to? You change it to, okay, when you change, what do you want to achieve when you change? You want to achieve what? Both have the same thing, right? So you wouldn't say, let's change it to denominator 5. You wouldn't say that. Because that's what Laurie brought up, right? You know you cannot express. At this point, 3/4 cannot be expressed as a 5, something over 5. That's not going to happen. But it's an obvious candidate now. What if you just what? What's the obvious common denominator, right? What's the obvious common denominator for both?
24.
That's not the most obvious. That's only you can know. Well, you are very sophisticated, right? Okay. Everybody would think the other one is a little easier, right? That would indeed equalize two fractions. Correct? Just multiply them. No subtlety. No subtlety. You try to do mathematics without subtlety. Unless absolutely necessary. The time will come when great ingenuity is involved. But as long as you can fend off all these fancy, tricky, subtle things, none of them. So then you know exactly what to do. Namely, you multiply this by 6. Well, the top should be multiplied by 6. 4, right? And that's what's going to be. So 24. Right? Now don't forget that this is the situation of equal denominator. Therefore, you just add the top, right? Add the numerator. So it's 18 plus 4 is 22. That's that. Well, there is to it about adding fractions. No least common multiple. However, when students now have a firm grasp of the concept of addition, they know how to do any problem to throw in there. And there's no reason why they can't, because what's there to learn? I mean, other than the most obvious, right? Then you should go back and say, there's some situations where if you get the least common multiple, things go much better. But you should think about and convince yourself that yes, this it's a skill that would be occasionally useful. But that's not the way you want to understand addition of fractions. No. It's just something as completely obvious as this. Just count. That's what you'll do. Just count. 18 plus 4. Now you can do addition, then you do subtraction. As you can see, right? Except there's one little problem. There is one subtlety about subtraction, which, again, no book would ever say it correctly. Namely, for example, Can I do that?
You can, but would you stay with your definition of a whole?
2 minus 3. Grade 5, you cannot do. Simply because you're not ready. Right? Same thing here. But yes, so you agree, right? Because, so to speak, 2 minus 3 you cannot do at this point because 2 is less than 3. Now for whole numbers, I'm not going to go into this. For whole number which is bigger than which, that you just count because, you know. But for fractions, you like to say, oh, we cannot do it yet because what? This is less than that. Okay. Tell me what is the meaning of one fraction being less than another? A over B, you say, is less than C over D. What's that mean?
A is to the left of C over D or whatever. No?
No, yes. But I want to point out to you, other than Malin, right? You read books, you never have a conception of what this means. Try it. Use what you know from the textbooks. What do you think that means? What do they say? They say, oh, it names a small amount than this one. What's that mean? It names a small, is that what they usually say? Names a small amount than this, names a small amount than this one. Still, what does it mean?
The length of that line segment A over B is smaller than the length of the line segment C.
But now you're already on the number 9, right?
You can take
It's to the
measuring
left.
cups too, because they're all the same, like little white plastic measuring cups, and they already have it on there. You'll have 1/4 and 1/3, and that's pretty visual.
What if I try this on you?
Not once.
Compare that with which is bigger? I don't know actually. But the point is not whether I can tell you which is bigger, but it's at least what does it mean to say one is bigger than the other? You get my point. Given 2 fractions, no matter what they are, I should be able to tell you what it means to say, just like this, right? When we first started, we said, what did we do? I erased it. We added 2 fractions. I just said, put them together. That total length is what we call the sum of the 2 fractions. I didn't know what it's going to be. Well, who cares? At that point, who cares? But I have a conception. This is what you're doing, and then you say, let's sit down and talk about it. Then we figure out, we can actually crank out a number like this, right? What is it? Yeah. We can actually crank out the explicit number. But we know what this is without the number. Right? Well, you know what this is. As I said, I want you to form the instinct. Basic, completely basic in doing mathematics. Is that anytime you talk about a concept, you have to ask what does it mean. So here's an example. Through fraction, I would say, I want to say one is smaller than the other. What does it mean? What's it mean? Smaller than the other. What am I talking about? So like this. When I say this, what comes to your mind? What exactly does it say? So I say, now come back to money. Right? So what you want to say is, well, what is A over B? It's a certain point on the number 9, is it?
It's to the left of the other one.
Right? Yes. So it's a certain point here. C over D is also a fraction, right? Represent a fraction. It's also some point on the number 9. So what that is like this. In this case, see, this point is to the left of this point. When this happens, that's what we mean by this. This point on the number 9 is to the left of this point on the number 9. But that's clear cut. There's no ambiguity, absolutely none. The trouble with textbooks Why they cannot tell you this? Well, you don't take my word for it. Go back and check your textbooks. I don't care whether it's elementary textbook, middle school textbook, high school textbook. They're never going to say it. Why they cannot say it? Because they cannot tell you what a fraction is. If you don't know what A over B is, how do you say this is smaller than that? What do you mean by that? How do you know what this is? I say that ghost on the upper left, on the 9th floor, is taller than the ghost on the 7th floor. What's that mean? Have you seen one? I thought you don't. So you have to know what they are before you can say something about them. So now we know what they are, point on the number line. Then I can say something. Namely, I would say this is less than this. If this on the number line, that's what it is. This to the left of this on the number line. Try it on your students. You may not see it right away, but if they begin to feel that whatever you tell them, you can actually explain exactly what it is. You build up the confidence. You build up the trust in you. That's how learning takes place. No learning can take place if they look at you with suspicion and take every word you say with a grain of salt. But that cannot happen. If you want to mathematics learning, that's not going to happen. No learning can take place. And that's the problem we have in the schools right now. The textbooks make students lose faith in whatever they hear and whatever they read.